Okay, good morning, good afternoon, good evening to all of you for day 2 of the COVISA all-member meeting. Thank you so much for joining today. We have a very interesting set of sessions planned, and we're so glad that you are taking time out of your busy schedule to join us. I wanted to just give a brief welcome and a little bit of an overview of what's happening today and tomorrow, as well as a look back of what happened yesterday. But before I do that, I want to thank our event sponsor, Genesis. So grateful for their generous contribution to this event and making it possible. If you have a chance, please stop by the Genesis booth and watch the video of their emerging vehicles. And yeah, thank you for doing that. And thank you, Genesis, for your gracious sponsorship. As you have already experienced, we are in this sort of immersive environment. This is not a point and click type of an event. You will need to move around and join stages to go to different parts of the event. So please consider that as you're walking around, but also as you're walking around, take time to say hello to colleagues, to clients, to new friends, and take advantage of the networking capability that this immersive experience offers you. For those of you who missed yesterday, especially the first session yesterday, you probably came to this event thinking it was a Geneva all-member meeting, and it is. But we announced yesterday a very important and exciting revelation of Geneva moving to a new brand name, new brand logo, pretty much new everything called COVISA. And COVISA is short for the Connected Vehicle Systems Alliance. And we launched that yesterday, not only during the first session, but also in the press release, a new website. You can visit covisa.global, and also a new wiki. Although the wiki is coming, it's a work very much in progress. And so please be patient with us as we work out the details of making sure everybody has credentials to join that wiki and to browse it. Most of the content will continue to be open, but we will be allowing for logins and that sort of thing. We're still sort of working that out. So right now, if you go to the at.projects.covisa.global, you'll see basically a rebranded wiki, but with the old Geneva content. And so, because a lot of that content is still very relevant to our activities today. And so give us a little bit of time to transition the wiki into a full COVISA mode. And for now, you can continue to use the Geneva wiki as you have in the past to get the latest information on CVII and other projects going on within COVISA now. So exciting news, and please tell your friends, your colleagues, your clients, your customers about this new exciting organization called COVISA as we aggressively move into the connected vehicle space, which is, again, an area that we've been working in for the last couple of years. So for the next 2 days, let me talk just briefly about the upcoming schedule. Today, most of the schedule is allocated to the Common Vehicle Interface Initiative work that's been active for quite some time. The first of 3 sessions will be around the standardization of data and services. So a lot of information about the vehicle signal specification, as well as the vehicle service catalog work. And so that'll take up a bit of the first session. The second session will be a lot more about the technology stack activities within CVII, which is all about tooling and supportive communication protocols and so forth. And so that's the second session. And then finally, the third session, which I'm really excited about, is about alignment and adoption. And what that means is that there are organizations that COVISA is working with now that are considering and are in the process of adopting and aligning their work to products and services that are coming out of COVISA, specifications, let me say, and not so much products and services, but for example, insurance and others. So that's an exciting message about alignment to other organizations and adoption of the work that we've already done in the connected vehicle space. Turning to tomorrow, we have three pretty exciting activities going on. One is the Android Automotive Special Interest Workshops. And then secondly, we have a really good program on in-vehicle payment. A portion of that will be about EV charging. And so there's sort of a dual approach there during that set of sessions, both in-vehicle commerce as well as the impact of EV charging to vehicle commerce and to the electric grid overall. And then finally, we'll have the automotive cybersecurity track, which has always been a great track and very highly relevant, talking about standards that are impacting the automotive landscape now regarding security. So that'll be tomorrow. We look forward to welcoming you back tomorrow. And so with that, I'm going to turn now to Gunnar Anderson. Gunnar is the technical lead for now Covisa. Gunnar has a extensive experience in automotive software, previous activities with Volvo Cars and other organizations. He's well respected in the industry. He's the one-stop shop, if you will, for all things related to Common Vehicle Interface Initiative. We appreciate his deep technical knowledge as well as his ability to talk about very high-level business issues and approaches. And so you're in good hands with Gunnar managing the rest of the sessions today. So Gunnar, I'm going to hand it off to you.
Thank you so much, Steve. Let's see if we can get the first slide up on the screen here. There we go. Great. So I want to just give you, hang on a second here. If I can control the slides. I wanted just to show you visually what Steve already said and give really brief comments about the plan in the technical track today. So first thing to say is that these different themes, we'll stick to them as best as we can. There are presentations generally related to these different topics. And let's see, my controls are not working. I'll just click my way through. That seems to work. Yeah, so the session one, real quick comments. I wanted to highlight the fact that Eric will, after my introduction of the general overview, will give us the overview of what the latest things in VSS. And I'm really looking forward to the presentation from Daniel on the VSSO and what you should expect. There's a little bit of understanding how these VSS and VSSO relate to each other and perhaps when to choose one or the other. So I think that's a very anticipated and interesting presentation for everyone. Second session, I will also give it a bit of overview for the tech stack, essentially the tooling, the software, everything that we're working on there. And then I will invite Magnus to the stage to help me talk about the VSC and the service catalog and the idea of creating a services model similar to the data model that we all are quite familiar with, I think. And then looking forward very much to Thomas's presentation as well on why vehicles need an event-driven framework. So that should be great. Session 3, as Steve mentioned, alignment and adoption. And also here, we're looking forward to really interesting presentations. I think in the eSync Alliance, I'm very excited about the ability of standard data and standard software over-the-air protocols coming together. And I also enjoy very much working with the insurance people. It's a new area for me, and there's a lot of interesting innovation. So really recommend that as well. Hopefully you'll get something out of my introduction there as well to how to think about alignment and these types of things. Right. One more thing I wanted to mention is that we don't have time today for deep introductions. Many of you listening are already active in CVII related projects, but those of you who are not, you might find it a little bit overwhelming to get thrown into the details immediately, but we'll do our best to give you an introduction. And I think we will have time for some questions in between. And if the time permits, then we will try to answer those immediately. And then I hope we will really get you into the standard projects where you can you can get all your questions answered, and really get into the meat of things. So there will be what I want to say, there will be references provided to you so that you can refer to those. Basically, as soon as you find your way to the CVII wiki, all the links you need are there. So you will be able to get the information you need. And as I said, hopefully join the weekly meetings. Okay, so let me do a little bit of introduction to the CVII. Generally, just quick updates on where we are at. I wanted to mention especially that the VSS project is active since actually several years, and in particular now it's very active and healthy. There will be more details, as I said, given by Eric on this, but just wanted to highlight the fact that there's release planning, there's interesting discussion on a few features. And the main point I wanted to say here is that the high-level discussions aren't closed. So VSS itself is an open project, but the CVII initiative is about finding that common standard data model, which means that we welcome your input on whether VSS should change or it's a combination of VSS and something else. That is something that we can work our way through. And you will find later today some more discussions and presentations that may maybe alter your way of thinking, hopefully a little bit around this, and get everyone on the track of getting to that standard way of describing and transferring data. So that's coming up later on. What's going on then in the tech stack? Very briefly, binary serialization is one area. And here you already see a concern many people have is, what about existing technologies? This is all about finding alignment and selecting good technologies when they are there and filling the gaps only when needed. So you can see things like protobuf and avro being very typical ways to describe data and get binary encoding of that. So those are the things we want to reuse and establish in this VSS ecosystem. Want to mention the great work done in W3C on the VISS specification. That's the W3C web protocol for accessing vehicle data, and that vehicle data is described in a VSS format. And so that's already now in public working draft status, and that's a great achievement. Also want to mention that we're talking about connecting VSS to various vehicle data sources. One of those specific ones are Android Automotive. So you will hear tomorrow, if you join the Android Automotive SIG presentations, we will talk about how we made progress on the automatic translation of VSS coded data into Android properties and tying all of this together into some consistent view of how you manage data in the entire system, which goes, of course, in vehicle and in cloud, and therefore Android needs to sort of fit into that context, we believe. And so there's interesting progress there on code generation driven by templates. Talking about other software frameworks being developed in various companies, it's great to see adoption of VSS. I mentioned two of them here on the slide, and essentially we're hearing more and more interesting big and small projects out there that are somewhat independently developed, and the project management being independent, but being part of what we consider that to be the tech stack. We see the tech stack as any and all technologies that facilitate the transfer of data and the invocation of services that follow these standard models that we're establishing. And so it's awesome to see that diversity and the increasing amount of projects out there. Our challenge a lot here is to talk about where do we find the commonalities also in the implementation, being able to work on common open source components that can be part of these bigger frameworks that are being built. Let's go to the next. Yeah, outreach and alignment. So just a little brief overview here. I want to highlight the fact that we have done so much great work reaching out to organizations, and also want to thank them for being so positive towards the collaboration on these important areas. The ISO extended vehicle working group, for example, is one that I'd like to highlight that we've had recent contact with several times, and the continuation of that discussion will go on for a while. And I think also we will later this week have a little bit of discussion of that, and that we placed into the CCS session. Other liaisons already mentioned desync and OPIN. I think these are worth highlighting, and I'm very happy to see them speaking and doing their own presentations today to talk about what we have achieved so far and what we are working on, basically. Already mentioned VSS supporting companies. The fact that we are seeing this kind of adoption also a little bit beyond the weekly meetings that we have. There's a range from common work all the way out to companies doing things on their own. We'd like to bring everyone into the fold and really be able to talk, because I think that's how we will get the best results, all of us. But it's great to see adoption, however it's being seen out there. So just wanted to highlight that. Looking then a little bit at our project structure, I don't intend to go through this in detail today, but just to highlight the fact that we have established a couple of projects, a couple of tracks, as I've already mentioned. You see them reflected in today's different sessions, but also that we have established sort of how to run projects underneath them that coordinate when needed and bring this whole thing forward. And I hope to see growth here as you all join these types of activities. There might be additional projects that need to be set up in order to really build this thing together. Another important slide is the next one. I'm not doing a lot of CVII introduction here, but it is really important to let you all know, if you are new to this, that we set this up as an initiative and use that word because we didn't want to see it as an isolated project doing a specific technology only, but really seeing it as the outreach to the industry to find this alignment. And we really felt when we started this together with W3C that no one else was stepping up to talk about how to align all of these different organizations. Everyone has their goal, and they have very similar goals in many cases when they are described. We all understand the advantage of standards. We understand that we need standard APIs. We need to figure out how to handle data in the industry. But this outreach and creating an initiative that reaches out and tries to get all of this aligned, this wasn't really done before we started, as far as we could see. And as been described previously in this conference, we hope, of course, that COVISA will be an even stronger force in being that central point of alignment, so that we can build the full vehicle systems in the future in a more effective way. So that's why we put this quote on some of our early slides, looking a year back, highlighting the fact that CVII is an initiative that sort of goes on top of all of the different projects. There's no doubt that COVISA is a member-driven organization, that VSS is a project that works on making VSS itself the best it could be. But CVII, on top of that, says that our ultimate goal in the initiative is to achieve this industry common model however we can. So it means that if you're on board with that idea, you should be here and talk to everyone else in order to make it happen. And that's why we want to really highlight that point. Okay, I think we're so far a bit ahead of schedule. I want to bring up Eric on the stage and get prepared for his presentation. And I suggest we continue with the presentations, and if we have some time towards the end for Q&A, we can take all of that at the same time. So please put your questions in the chat, and welcome Eric to bring us through some of the latest VSS updates. Eric from Bosch is a very active engineer in our VSS project and much appreciated by everyone. So thanks, Eric, for being here.
Thank you very much. So let me see if I can get the right slide up here. Is it that? Yes. So hello, everyone. So my name is Erik Jägervall. I'm working as a senior software architect for Bosch in Sweden. And I'm, well, one of all of us in the community that actively working on improving the vehicle signal specification. So I would like to take some minutes to tell a little bit what's happening in the VSS part and the VSS tooling part of CVII that Gunnar just talked about, because as Gunnar said, CVII is a big topic involving multiple projects. My little corner of it is primarily VSS and the VSS tooling. And the vehicle signal specification, for if someone of you doesn't know about it, it's about, one thing is a syntax to define signals that you could read or set in the vehicle, actuators, sensors, and attributes like vehicle speed, engine oil level, and other things. And this one has existed for a while, and now it's started to become quite mature. So it's not that much that happening in the actual signal catalog. Like, there has been a few items added over the last year, like for instance, engine oil level, distance to service. It's typically so that we see now that if someone is starting to use VSS and they notice that some signal is missing, then you have in VSS two options. You can have it as a proprietary signal, or you could try to commit it to the standardized catalog. So we see a few signals coming up, but it's not that much. So it seems that it's starting to become quite complete. We have also done some minor adaptations concerning data types, like if, for instance, something should be represented as an int or a float, if something should just be a sensor, that is something that you just can read, or if it also should be an actuator, so that you also can write it. So that is slowly evolving. We get proposals now and then. And by the way, if you're interested in joining, we have a weekly meeting on Tuesdays, and more participants are fun, so feel free to join. The second part of VSS is concerns tooling that we have for, well, handling these signals. And we have in the past had some various toolings to convert the VSS specification to CSV file, a comma separated value file, to convert it to some other format. Now they're also coming up some other tools, for instance, to convert it to a protobuf representation, a GraphQL representation. And we also see that there is a lot of interest there in actually improving the tools we have there so that they become more stable and in general more better, basically transforming them from a sort of a prototype state where some of the tools have been to a more production ready state. And as part of this, we have ongoing discussion how to introduce and support other user-defined types, because as of today in VSS we have defined a set of data types and units that can be used, for instance, that we support int32, int64, float, and so on, and as well as some units like meters per second and degrees Celsius. But both for extension of a VSS standard catalog, but also for adding proprietary signals, you might need to support other units. You might need to, for instance, if it would be so that you would need to support a 4-bit data for your system, then we need to find a way how that can be represented and supported in our tools. And there we see quite a lot of activity. We also improving continuous integration, including some unit tests. There have been some general quality improvements. The intention there is that as soon as there is a pull request coming up with a change, we check that whether the existing tools are affected, and we try to fix that. And the general working model there, if you want to contribute, is that you create pull requests, you create issues, and then we bring it up on the weekly meetings and discuss if a change seems to be reasonable. So what is happening more here on the VSS in the near future? Well, as I said, this about flexible usage of units and how that can be supported in the tools is one topic. There is also a topic that has been going on for a while that's called Vss Layers. And this is the question of how should you adapt the standard catalog for your needs, because as of today we have a standard catalog that is growing quite big, and not all vehicles will support all values there, all signals. For attributes like length and weight of a vehicle, you might want to have static definitions of what that should be. You might want to add vehicle specific parts. You may want to subtract certain parts. And there, how you should do that in a way, how you should use the VSS spec so that it can show what signals exist and are supported for my particular vehicle. That is a topic that's being discussed. And also now we are coming up with this the vehicle service catalog, how to handle certain services in a vehicle. Could be a software update, could be something related to diagnosis, and this is quite closely related to VSS, because in some cases you might need to read certain data that then might be used in a service. So how the vehicle signal specification can coexist together with a vehicle service catalog is a topic that is being currently discussed. Also about handling more structured data, because as of today we have signals, but they are on a specific value, but sometimes you might need to do atomic change of a certain set of signals. And as of today, VSS have limited support of that. And also if we see in future use cases, you might want to specify that a certain signal not is just a basic type like integer, but rather a structure of a handful of types. And how that should be handled in VSS is also an open topic that's currently being discussed. So we see a lot of interest in VSS. It's quite fun to see that there is a steady flow of pull requests. coming in, and your contribution is mostly welcome. So that was about what I had to say. Gunnar.
All right, thank you so much, Eric. Really appreciate that. So next, I would like to introduce Daniel Wilms from BMW. Daniel is really a pillar in all of our work when it comes to these data standards. He's the maintainer of the VSS repositories at Geneva and now at CVII. And I'm really looking forward to Daniel giving an even broader view of the future of data and how we build VSS and VSSO together as a strong proposal for this common data model that we're looking to achieve. So welcome, Daniel.
Okay, thanks, Gunnar. Thanks for the introduction. And yeah, I'm really happy to be here today. Who am I? I'm Daniel. I'm working at the BMW Technology Office in Israel. Yeah, I'm quite a bit around here in the topic of VSS and ontology. What I want to do today is like basically give a couple of more details how this looks, and then as well look beyond that. So of course VSS is perfect to this, or not perfect, but it's really good to describe like basically the signals and the structure and like basically transport those as it's protocol agnostic. But there are some things, especially if it comes to context to other domains, where it maybe fall a bit short, and like then I want to motivate a bit why we do the work of the ontology, like converting it in, or like bringing it into the ontology world, and what the motivation behind it is, and how we did it for you to understand. So first of all, let's look at the structure of VSS as it's written here. Like the specification is basically a taxonomy for attributes, sensors, and actuators. What Eric said before. That means that basically we start from the vehicle, and then basically the information lies in the leaves, which are here marked as red. So important to understand for later is basically we just have one relationship. Now, like in a normal taxonomy, you would have like narrow and broader. Here is basically part of a cabin is a part of a vehicle, but not like a more specific vehicle. So basically, but we have at the end one relationship here, like a cabin is a part of the vehicle, a seat is part of the cabin, and so on, and then the signal is part of the physical thing. So how does it look like? Eric said before already. It's like it's a YAML specification. So in the upper right corner, you see an example. Like what does the YAML specification contain of? First of all, it's one name which is unique within the VSS scope. Here we have like speed as one example. We have the type, which is a sensor. Like there are different types. It can be a branch, which basically classifies everything which is under the lines, orders it basically the branches and signals underneath. We have sensors, which means like values which you expect to be updated and which you can read. We have actuators. Those are basically sensors which you can where you can have the possibility to write if you have the permission. And then we have attribute, something like the vehicle identification, which you don't accept to change at least in one life cycle. So there were some discussions around that. We can go further into detail in a private session if you're interested. So these are the different types we offer. Then we have data types, which is a longer list, and units basically define the signal which is coming to give like implementers the possibility to basically adapt their code in that direction, and to give the data provider the hint how you would like to or how you have to communicate your signal that it's understood on the other side. And then last we have a description. Here is gives basically a bit of context of the signal itself, so that it's understandable, because the name might be confusing. So this gives you a chance to give a broader description. But what would be the YAML just as a specification? So on top, as Eric mentioned, we have tooling, which does different serialization, which extended to different serialization formats. But it's important to note that it's basically protocol agnostic. We had before VISS, what Gunnar mentioned, like it's one possible way of transport the data. Like there are others like GraphQL or like your proprietary format. The important thing is that you basically the data model, the data structure, and the data type and unit, and like how you name things. Basically, it's the same for every protocol you're using VSS with. So you could say, okay, like that's good enough. That's where we are. Like YAML is the specification format with both, and there are really good things about it. It's easy to read, to parse, and to understand. So everybody, like as well inside, if the YAML catalog, if you're not afraid of an editor, it's like really, it's like you immediately understand what it's about. And like the tooling around it is like Python tooling is as well, like easy to build on top of it. Like the tooling, like as said, if you have one relation, the tooling is really not really close to bound to VSS, but it can be used as well with other definitions which follow the rule set which VSS defines. And another point which is important, I think, is it's only text. So at the end, you can use like the normal development tools you use for code. You can do the same pull request as described before. We don't differ like from the extension of the specification in the process, in the development process. We don't differ from any other code project. So it's like basically that's what people know at the end. And but then it comes like there are as well a couple of limitations. As said before, like the names in VSS are like unique in their namespace. So it's like as we see later, it's hard to refer from one domain to another, because it's defined in the YAML file, and then the reference to other domains is difficult. And the other part is that we don't basically define relations. What we define is like the tree structure, but not different relations between the nodes. And so that brings us to like a bit of the conceptual work we have to do before. So that we understand what I'm talking about later. So there's something called the data information knowledge and wisdom pyramid, which you see here. So what is it about? Like everything starts with data, basically unstructured data, like some kind of application, some kind of ECUs, like it communicates to the outside. That comes in, like you can put that data into a context, and that's basically what VSS does, is like create information out of it. So you know that it's vehicle speed, and you know that it's like it's coming in kilometers per hour. You know the data type behind it, and the description. You understand the signal. But what it doesn't do, it doesn't put like the information in context. You don't know, like 130 kilometers per hour can be totally fine on a highway. Next to school is maybe not so good. Like same with material. Some plastic is perfectly fine if you want to build a Lego block, but if you want to eat it, it's not good. So you need more more context around the data to really like know what to do with it, and where to use it and how to act on it. And there's like where knowledge comes into place, where you put those different domains together and build a context around is that you securely can put on rules on top, which then say, okay, like in case of the highway, 130 kilometers per hour is okay, and the city is not. And if you have all the information from maybe two different services, or like if you put them together, you can basically create rules which apply to the context you're giving to. And where do we place VSS? So that's I started explaining it already when I introduced the pyramid. It's basically on the information layer. So we have the vehicle data, which is then well described, and which you where you can then put a protocol on top, like VISS, for example. You can have your own proprietary protocol, or like some other digital twin which consumes the data. So if you are in the vehicle space, you know what you're subscribing to, and you know what you are getting. But now let's look at a bit different domain, and let's try to have the same the same structure there. So if you look at, I hope you can read it better than me, otherwise contrast is a bit bad. Okay, let's look at a person. Like if you have like this one relationship part of it's perfectly to define a person anatomically, but not like how it's used maybe in a customer way. Like a person might have an address and might have the work address and a phone, and like have personal information around it, a credit card, and it might the person might own a vehicle, the person might drive a vehicle, or it might use car sharing for it. So there are different relations to it. So first, like the one property, like part of as we have in the vehicle structure where it makes sense, we don't have. So basically the person itself is already a multi-domain taxonomy, because you look at the different aspects and you bring them together in different relations. So relationships are first of all important. The second thing is, okay, we have VSS defined. Now we want to say, okay, like this person owns a vehicle, or this person, this specific person drives a vehicle. And there is as well, like, how do you do that in practice? So you have basically two YAML specification, and you can copy it, you can use include, but nothing is like everything is a little bit hackish around it. So you have to come up with your own solution. And then if you are an application developer and you want to say, okay, I want to link the vehicle with the person data I become, so you have to do manual mapping. So you have to understand like the person world, you have to understand the vehicle world, and you have to understand how to bring those two together and how to integrate those. And that's that way that gets complicated. But there's a good news. Like there's already something, some standard which defines how to do it, and that's basically in the WSO3 world. If we talk about ontologies, like we have the possibility to exactly describe those relations. So instead of bringing that into our YAML specification, there's something we can leverage, which is already well defined out there, and which can be used straight away. But some people say, okay, like, oh, well, now you define everything new from scratch, and of course that would be a valid point if we would do so. But as I said, we have tooling before. We understand like VSS, we can parse it, we can understand it, and then we can use the tooling to build basically the ontology of the concepts we have defined. We will see later how. Let's look a bit into the history of VSSO, how it started. So it started with the work of Benjamin Klotz, who was working as a PhD student at BMW. And we were working together, and we were looking at VSS, and we were thinking, okay, hey, we need those relations I was talking about before. And like VSS was really nice in a way, as described before, because it only defines the data model. Often you have some protocol aspect or something within it, and sometimes it's behind closed doors. You need a license to read it. So we thought, okay, we want to have something open and something which is protocol agnostic. So we found then VSS, which was already well defined. Then it had some things which didn't map really well onto the ontology world, and this was what we then maybe Benjamin, but he listed that then, and slowly with the process we described before, we thought, okay, like maybe VSS already can benefit of it, and if we do so, then a transformation, automatic transformation through tooling is possible to achieve. We created pull requests. We had a lot of discussion, like things like instantiations, like attribute and the signal trees, or putting it together. So this is something we defined, and then like beginning of the year, we could then finally release version 2.0, which had a lot of those changes we discussed, and even more which came up through the discussion and the input of others. We could put into the version 2.0, and now it's on the recommendation track of the WCC and is discussed in the WCC automotive group in the business group of it. But what do we want to cover with VSSO? So we have three use case cluster. One is like get the current data of the vehicle. The things I said before. Okay, like if it's higher than in a specific location, like put out a warning. What are the vehicle of the brand BMW we have in our system, or like give me the specific information about a certain vehicle. Those are all basically information which you can request and ask the graph to answer those questions for you. We have dynamic vehicle data over time. There's already a standard for it, and that's one important point. What we want to achieve is we don't want to reinvent the wheel, but we want to use VSSO as a domain ontology for things which are already there. So one is the sole use of VSSO in combination with other domains. The second one is like data analysis over time. They are already ontology, like IoT stream and those are things we don't want to include in the ontology itself, but say, okay, use VSSO as a domain ontology for one of those and align with the concept. So like one requirement or one use case we had in mind was like to work nicely with those ontologies which are already out there. And the third one is the interaction with other data to make it easy. So there are like Web of Things, for example, is a small example how you can define your interfaces, how you can map ontology-based description of your service with your underlying services, which give the data out in a non-structured format. There you can define, okay, like these are like actuators, these are sensors of different domains, and this is how you interact with this. It's basically an interaction interface. And again, VSSO should be just there as a domain ontology. So these are the use cases which are hard to realize with only VSS. That one maybe a bit more, but as said before, because we don't have the relation between things which we can define with VSSO, it's the integration efforts can be quite a bit harder. So how did we build up VSSO? We started with a core ontology. We looked at the different concepts VSS has to offer. As said before, we have branches, we have attributes, we have sensors and actuators. So these are the basic concepts of the vehicles. The branches define at the end vehicle components, and we have static and dynamic vehicle properties like in VSS attributes and versus sensors and actuators. And we gave that a bit of structure. So I would highly recommend to look and on the there are some links. At the end, I don't go into detail because it's a long discussion and it's still an ongoing discussion. So you are as well invited to contribute there. So from there, we have generated concepts. That's all the branches at least we define in VSS. Once we have the core ontology, it's not a big issue to map those in VSS defined concepts onto the ontology itself. And the third one is then use the third layer is then using VSSO as a domain ontology for the other ontologies out there, IoT stream and Web of Things, and SS and SOSA are just a couple of examples for you. So that comes to the last slide. It's like, where do you find that information? I guess the slides will be shared afterwards, that you can get the information and that you can read a bit more about it. I'm always happy to answer questions. Just send an email or contact me, and yeah, let me know if you have any questions. We have usually in the Tuesday meetings, we have always a discussion as well on VSSO. It was a bit silent because the input was right now, the focus was more on VSS. So if you are really interested in the ontology space, yeah, you are always invited to come to the discussion, raise issues, and let us know.
Yeah. Thank you very much, Daniel. So If you want to ask any questions, you can go to the chat window. You go to the menu on the left where you see the people icon, and then you go to the main stage chat and put your question in there. Main stage. We have one question coming in. Let's start with that one. How is VSS different from DLT? DLT/DET. Is VSS independent of protocol? Can I correlate YAML with DBC file? I think those are several questions. Let's start maybe with the first one. Is it independent of protocol? Do any of you two want to take that one?
Yeah, I can start. Well, on the top level, VSS in itself is not saying anything about the protocol. It's just saying that there is, for instance, a signal called vehicle speed with a certain unit and a certain data type. Then you of course can have other things like the Vss, the service specific, the Vss specification, where you sort of specify that it should be done by a certain protocol. And of course, we can have some of the tooling there that takes a VSS specification and translates it into some other format that can be used by some other protocol. But in itself, VSS doesn't say anything about how you physically will get or read or subscribe or do anything with that value. It just says that this is the identifier, this is the type.
Mm-hmm. I agree. The second question was, can I correlate the YAML with the DBC file? You're familiar with DBC as well, Eric and Daniel, so.
I'm not the expert here, so before I say something wrong, I wouldn't say too much. I would have an opinion, but I skip that for now.
I might take that one. So with DBC file, I think you mean kind of a de facto standard for CAN signal descriptions. And this, as well as many other similar topics, are always on our agenda. How to take an existing signal source and sort of translate it into the VSS format, and also correlate signals into their VSS equivalents. And so there are some work on that. I don't think we have an out-of-the-box solution for DBC, but we do have general principles. For example, if we look at the Android work, how to describe such translations. And so it's definitely a possibility and something that we're ready to develop any time someone steps up and says, now is the time to do it. So that is possible. I think we have time for one more question at least. So someone states here that most likely data signals will be described using ARXML. That is true in many cases as well, also for services that are exposed on an AUTOSAR-based system. We work a lot in these discussions with basically formats that we try to keep independent of any implementation. But both in the area of services and a little bit on the data, we have work on how to translate or tie this into AUTOSAR technology. So that is a very central part of the development for sure. Can VSS be used for inter-EC communication? Yes, it can. And different companies have different focus on where they want to start. In this work, we really promote the idea that the common data model we're aiming for should work inside of vehicles as well as in the cloud and in the boundaries. And so you get the maximum benefit if you use it as widely as possible, but different companies start in different places when it comes to actually implementing and making perhaps some translations where necessary to existing legacy or just data sources that have a good definition and therefore just need that translation. And so, yes, some companies are definitely focused on inside vehicle and inter-ECU communication, as well as the cloud side. Right, I think that's time for us. As I mentioned, we have references. We're happy to come back to your questions when next time we have the ability to speak to each other, and we hope you join the regular meetings and this initiative so that we can work on this together, and looking towards a great future, I think, with a new COVISA organization to organize all of this work. So very happy to return to your questions at another time. And now we're going to break for 5 minutes. We should be back at the top of the hour. Thanks so much for joining us, and see you very soon for the next session.